Hey Globey, today we're going to Mars. Well, not actually, but we're going to talk about going to Mars with NASA's proposed Ares mission. Ares is an acronym. It stands for Aerial Regional Scale Environmental Survey of Mars. Ares is also the name of the Greek god of war, but the name Mars is named after the Roman god of war. Some people refer to NASA's Ares as the Mars airplane. The mission is to send an airplane to Mars so it can soar above the surface of Mars and gather important information about the planet. The plane is robotic, which means there are no pilots on board. One of the keys to this important mission is figuring out how to get Ares to Mars. Mars is very far from Earth, and the exact distance is constantly changing as Mars' orbit changes. At its nearest point, Mars is about 56 million kilometers from Earth. That's about 35 million miles. At its farthest point, Mars is about 400 million kilometers away. That's about 250 million miles. With distances like that, it's much too far to actually fly an airplane to Mars. So NASA's decided to put Ares inside of a rocket that will carry it through space. But that now introduces a whole new set of problems, like how you get a giant airplane like Ares to fit inside a rocket. Dr. Joel Levine is the lead scientist and principal investigator for the Ares project at NASA's Langley Research Center, and he's going to tell us how NASA solved that problem.
We fly Ares to Mars in a spacecraft. The trip to Mars is 6 to 7 months. During that time, Ares is in the spacecraft, and it's in something called an aeroshell. An aeroshell is like a big garbage can. Now, the aeroshell is only 9 feet across. Its diameter is 9 feet across. Ares, when it's flying, has a wingspan of 21 feet, and it's 17 feet long. It's a pretty large airplane. So the question is, how do you get an airplane that has a 21-foot wingspan and is 17 feet long in a garbage can or aeroshell that's only 9 feet across? And that's been the major problem, how to package the airplane so we can get it to Mars. We cannot put the airplane in the spacecraft because it's much too big. The spacecraft won't fit on the rocket. So what we've decided to do is fold the airplane. We fold the right wing, we fold the left wing, we fold the tail over the body of the plane.
But what happens once the rocket reaches Mars? How does Ares unfold itself? We're going to talk about that in a second. Does everyone know what an atmosphere is? Well, in case you don't, an atmosphere is made up of different kinds of gases that surround an object, like our Earth or the Moon. Earth's atmosphere contains gases such as nitrogen, oxygen, argon, water vapor, carbon dioxide, and ozone. Oxygen, of course, is what we breathe, and it's one of the reasons life can exist on our planet. But other bodies in our solar system have much different atmospheres than Earth's. The Moon's atmosphere, for example, is so thin that many people believe it doesn't have an atmosphere at all. But it does. It's about 1/trillionth the thickness of Earth's, though. Take a look at that number. That's a lot of zeros, isn't it? The atmosphere of Mars isn't nearly as thin as the Moon's, but it's thinner than Earth's. It's about 1/100th the thickness of Earth's atmosphere. Its atmosphere contains mostly carbon dioxide, which makes up about 95% of the atmosphere. It also has nitrogen, argon, and very small amounts of carbon monoxide, oxygen, and water vapor. Because there is so much carbon dioxide, the atmosphere is poisonous to us. So you'd have to wear a protective spacesuit with your own oxygen supply if you ever visited Mars. Because the atmosphere is so much thinner on Mars, scientists had to figure out how Ares would react to it. Meaning, how well would the airplane do flying through Mars' thin atmosphere? And how would the thin atmosphere of Mars affect Ares as it tried to unfold from the rocket?
As it approaches Mars, the aeroshell automatically is jettisoned from the spacecraft. The aeroshell is attracted by the gravitational field of Mars. Even though the atmosphere of Mars is very thin, it's coming in at 18,000 miles an hour. And you know, if you rub your hands fast, you feel the heat. Well, that's frictional heating. And that's what happens when the aeroshell enters the thin atmosphere of Mars because it's traveling so fast. The thermal tiles on the bottom side of the aeroshell absorb this heat energy so that the aeroshell doesn't burn up. And then, depending on the altitude, a parachute opens up, and the aeroshell is now on a parachute, and it stays on the parachute for several minutes. It slows it down. It slows it from 18,000 miles an hour to a much slower speed of, let's say, 100 miles an hour. Then the bottom of the aeroshell is jettisoned, and for the first time, the airplane is exposed to the Mars atmosphere.
Ares will then fly across the surface of Mars and gather information for NASA scientists back here on Earth. So, Globey, that's really fascinating what scientists and engineers like Dr. Levine are doing. Each planet in our solar system has a unique atmosphere, and learning more about atmospheres is so important when we consider exploring other worlds.